shot right here. Hopefully you guys can see it. Let me adjust the camera. Bam. Okay, I think that's good. Okay. Now I have a number of items at the top right here. You got atomic number, mass number, electrons, neutrons, nucleons, nuclear charge. And I have three guys on the side right here. I have magnesium, right? Okay, 2412. I have magnesium 2412 again, but it's a little +2 right there. And I have sulfur S, okay, 3316 minus 2. Alrighty? Now here's the deal, guys. When you're filling out a chart like this, or you're doing counting subatomic particles, you always have to ask yourself, is the atom in question, is it neutral, okay, or am I dealing with an ion, okay? So you look at the particular ion or atom that they give you, and you see if there's a charge or not. Okay, so we look over here in magnesium, right? You look at this top right corner in the exponent area, there's nothing there, there's no positive, there's a negative. So you can make the assumption, right, that this guy is neutral. All right, bam, done. Okay, now that helps us a lot because we remember, right, if something is neutral, the protons equals to the number of electrons. Okay, protons, the charge guys will be equal. All right, so what's the atomic number of magnesium? Now guys, I don't have my reference table here, but I should. But you should always have your reference table with you. You flip it open, the atomic number is going to be 12. Okay, now here's the other deal. The bottom number here, folks, represents the atomic number. But let's say they wrote down, right, magnesium dash 24, right? You would need your reference table to figure out the atomic number. But it just so happens they gave it to you here. The bottom number is the atomic number. So if you know the atomic number, what other particle automatically you can write that number in for? Atomic number represents number of protons. Yes, okay? So, number of protons. I think I have to make a column for that guy, right? Put protons right here. So the number of protons is, okay, the number of protons is also 12. Okay, so atomic number, number of protons, same thing. Now, once again, guys, if the atom is neutral and the protons equals electrons, we can write a 12 there also. So we got three guys, one stone. Bam, done. Okay? Alrighty. Mass number is given in the top right here. Okay? Mass number is in the top, and that's 24, so you just write that in. Bam. Now, what's the mass number? What gives the atom its mass? We talked about it in the previously, right? The mass number is made up of what? The protons and the neutrons. Okay, so we gotta keep that in mind. Now they here are asking you to find the number of neutrons. Now guys, very important, the mass number, right? The mass number, take away the atomic number. Okay, that gives you the number of neutrons. Okay, so 24 protons and neutrons, take away just the protons, leaves you with neutrons. Okay, so 24 minus 12 is 12, okay? No problem. Now, what's the nucleons, people? All right? Remember, nucleons are the particles in the nucleus, which are the protons and the neutrons, and it just so happens, right, that also represents mass number, right? So you sort of kind of see a pattern here. So you're going to put your 24 for the nucleons. Now, what's the nuclear charge going to be? What do you focus on? What's charged in the nucleus? We know that the protons, right, are the guys that are charged in the nucleus, right? We have neutrons also, but they don't have no charge, so we're gonna ignore those guys for now. So we know from experience, we got atomic number 12, or 12 protons. We're gonna put a positive 12 there. Always put a positive, right? Positive and the magnitude of the number. Okay, we're gonna move on. We have Mg plus 2. Now the plus 2, guys, means what? It means you have a charged atom. You have an ion on your hands, people. Now, plus 2, positive 2, means that you lost, okay, positive ion, okay, means that you lost electrons, okay? Very, very important. Make a note of that. So normally, this guy, magnesium, would have 12 electrons, but he lost 2 of these electrons, guys. Okay, so you have to do a simple subtraction. So how many protons does magnesium have? Atomic number is 12, okay? 12 again, 12 protons. Now for electrons, it would have been 12, but since it's positive 2, meaning he lost 2 electrons, 12 minus 2 is 10, okay? Be careful with that. The mass number number stays the same, people. 24 for the top, put that right there, bam, okay. To find the neutrons, same procedure. Mass number, take away atomic number, right? So it's gonna be the mass number 24, take away the atomic number of 12, that gives you 12 right there, okay. What's the nucleons? Protons and neutrons, 24, that goes there, okay? Alrighty, what's the nuclear charge? Number of protons with a positive in front, positive 12, okay? So for ions, right, it's basically the same thing as a neutral atom, but you have to make an adjustment with the electrons, whether you're gonna add or subtract, okay? So if you have a positive charge, you subtract the number of electrons in the neutral amount. If you got a negative charge, like this sulfur, you're gonna add, okay, to the neutral amount that it normally was. Okay, so sulfur here, this guy right here has bottom number 16, so I know my atomic number is 16, right? I also know the number of protons is 16, because they go hand in hand, right? Atomic number of protons. What's the mass number? It's given to us at the top right here, right? So that's 33. Okay? All right, you take a breath. Okay, so I know my mass number is 33. I know my atomic number is 16. I know my protons are 16. How many electrons? Okay, now this is sulfur, right? Normally, it would have the same number of protons and electrons, which would be 16, right? But since it says -2, what do you got to do? It will be the normal 16 electrons plus 2 more. So 16 plus 2 gives you 18. Okay, normally neutral, it would have had 16, but -2 means it gained 2 more electrons. Now we're going to talk about gaining and losing electrons when we get to bonding, guys, so don't stress, okay? No problem. How many neutrons? You simply do a subtraction between the mass number, take away the atomic number. The mass number is 33, so 33 take away 16 is 17, okay? What's the nucleons? The nucleons reflects the mass number, the protons and neutrons, which is 33 in terms of the nucleons, all right? And the last one, nuclear charge. Okay, you guys tell me what the nuclear charge is going to be. The sulfur, got 16 protons, you got 33 as its mass number. Remember, the nuclear charge corresponds with the number of protons, right? With a positive in front. So, you got 16 protons, or atomic number 16, you have positive 16 for the nuclear charge, and you're done. Okay, so we got that guy right there. All right, folks, study hard, be well.